Hey there! In the last video, we saw what rocket propulsion actually is and the basic principles behind it. As explained at the ending of that video, there are several types of rocket propulsion, with different engines and propellants to power them. In this video, we're going to be taking a look at two of the more widely used methods of rocket propulsion: solid rocket motors and liquid rocket engines. If you haven't watched the first video, I highly recommend you do so with the link up here. Here are the timestamps for the various sections of this video, so feel free to skip ahead. Well, what are we waiting for? Let's get spacey. Now, both of these methods of rocket propulsion have some commonality. Firstly, both of them use the same propellant, which is a fuel and an oxidizer. Secondly, the method in which they produce the thrust is similar. Both of them mix the fuel and the oxidizer to expel flames out the back of the rocket. Now let's look at each of them in some more detail. Solid rockets were actually developed many years ago by the Chinese and first used in fireworks. For our explanation, we'll use the example of the two solid rocket boosters at the sides of the space shuttle, a spacecraft built by the US. Here's a cross-section of the inside of one of the solid rocket boosters. The black material you see here is a solid mixture of the desired fuel and oxidizer. This hole here is known as the combustion chamber and carries the flames produced by the rocket. To light the engine, you started off with a miniature rocket motor at the very top of the rocket. This starts the burning of the solid propellant, which shoots flames all the way down through the combustion chamber. So a solid rocket in its essence is when you take the fuel and oxidizer, mix them together in a specific manner to be put in the rocket, leaving a hole in the middle. Then you ignite it, and the two burn up to produce flames through the hole, which in turn produces thrust. Here's one of the fundamental advantages of solid rockets. They're fairly simple and involve relatively little complexity. However, a major downside to using solid rocket motors is that the thrust produced cannot be controlled. Additionally, the engine cannot stop or shut down until all of the propellant is burnt out. So we need an alternative which can perform these additional functions, and that's where liquid rocket engines come in. Developed in the early 20th century by Professor Robert Goddard, the liquid rocket engines were a revolutionary invention. Liquid rockets consist of two main parts: the propellant tanks, which store the propellant, and the engines, which combine the propellant to produce flames. Let's use the example of SpaceX's Falcon 9 first stage. Speaking of stages, rocket staging is an important process and will be discussed in a future video, so watch out for that. The Falcon 9 used 9 Merlin engines to produce thrust using the propellant stored in its tanks. Here is the oxygen tank, and below it is the fuel tank. The propellant here is carried to the engines using pipes as well as pumps, which help move the propellant into the engines in an efficient manner. The engine is where the thrust is actually produced, and there are a few important design features that help it to do so. Here's a basic schematic of the shape of a rocket engine. This odd shape is called a converging-diverging nozzle. Up here is the combustion chamber, and it's here that the fuel and oxidizer meet. The molecules here are of high temperature and pressure, but are not directed in a single direction. This is where the throat here comes in. The throat gets the random thermal motion of the molecules here and gets it to a supersonic velocity, and in the process, channels the motion in one singular direction. The converging-diverging nozzle is therefore one of the most important features of an efficient rocket engine. Now, unlike solid rockets, liquid rocket engines can control the thrust by limiting the propellant that is carried into the combustion chamber. So that's solid rocket motors and liquid rocket engines. They're the more commonly used methods of rocket propulsion as of now. There are a few other methods of rocket propulsion, like nuclear thermal engines and ion engines, which will be discussed in the next video. I hope you enjoyed this video and found it interesting. Leave a comment below for any questions or suggestions. Like and subscribe if you feel like it, And until next time, stay spacey.